Welcome back to the Wall Street Podcast. Today we're doing a deep dive into Morgan Stanley's Greater China Semiconductors Outlook report. It just came out September 15th, 2025.
That's right. And this report, well, it gives a refreshed look at AI semiconductors. It digs into China's domestic GPU supply situation, TSMC's advanced packaging capacity, also the rise of custom AI ASICs, and what's next with edge AI and wafer-on-wafer. Importantly, they're keeping an attractive view on the industry for Greater China tech semis.
Okay, so quite a bit to unpack there. The analysis seems to flag some really critical trends shaping things.
Definitely. Let's start with the first big one, AI semis and China's GPU push. Generative AI is just driving demand like crazy for these chips. Now, there's a recovery projected for the second half of 2025, but potential tariff costs are a factor to watch.
Right.
But the really striking part, China's aiming for 82% GPU self-sufficiency by 2027.
82%. That's a huge leap from, what, 34% in 2024?
Exactly. It's a massive jump. And they're projecting local GPU revenue hitting RMB 287 billion by 2027, with Sensmic, their big domestic foundry, playing a key role. We see examples like DeepSeek showing cheaper inferencing, but there's still the question of NVIDIA's B30 shipments that could, impact how smoothly the domestic supply chain scales up.
So a very aggressive domestic push, clearly trying to reduce that reliance on foreign tech, but international players like NVIDIA are still a major force. What about the actual manufacturing? Any bottlenecks there affecting the global picture?
Yes, and that brings us neatly to advanced packaging as a critical bottleneck, specifically TSMC's CoWoS capacity, this chip-on-wafer-on-substrate.
CoWoS, that advanced packaging that stacks chips for better performance.
Precisely. It's vital for these high-powered AI chips. TSMC's plans are to expand capacity significantly, up to 93,000 wafers per month by 2026. They're basically doubling it in 2025.
Doubling. Wow.
But, and this is key, they expect a deceleration in that growth rate in 2026. And NVIDIA, they're the biggest customer by far. They're set to consume most of that projected $15 billion in AI wafer consumption and 16 billion gigabits of HBM supply in 2025.
HBM being high bandwidth memory.
Correct. So it really shows that GPU supply and demand need, further alignment. The packaging is crucial.
A very specific high-tech manufacturing step acting as a global choke point for AI.
Interesting. Looking beyond the current generation then, what's the report saying about future tech?
Okay, third area, ASICs and future technologies. First, custom AI ASICs, that's application-specific integrated circuits. That market's projected to hit $21 billion in 2025, mainly driven by cloud service provider projects, your CSPs.
Right, the big cloud players needing custom silicon.
Exactly. And then there's wafer-on-wafer, or WoW technology. The report highlights this as a potential solution for improving bandwidth and power, especially important for edge AI.
Wafer on wafer, stacking whole wafers. Yes. It drastically shortens signal paths. Offers real cost savings to maybe around $80 per sauce per system on chip. The growth potential is huge, a projected 257% CAGR between 2025 and 2030. That's looking at a $6 billion total addressable market by 2030.
A $6 billion market just for WoW.
And one more related point. The outlook for cloud semis in general looks brighter. CapEx from the top 4 CSPs was up 67% year over year in the second quarter of 2025. Strong investment there.
Okay, that gives us a solid overview. Let's dig into some implications now. First question, back to China's GPU goals. That 82% self-sufficiency target by 2027, how viable does the report really think that is?
Well, the report definitely paints it as ambitious,
Sure.
Very ambitious. While you have domestic players like DeepSeek showing progress, like cheaper inferencing, the potential impact, the dilution from NVIDIA's next-gen B30 shipments is real. It suggests that the domestic supply chain needs, frankly, significant scaling and more advanced capabilities to really hit that target and compete globally. It's really about the hurdles, both capital and tech, in trying to build out a separate semiconductor ecosystem.
So ambition is high, but execution and competition remain major challenges. Okay, second point, CoWoS, the packaging bottleneck. You mentioned an anticipated slowdown in its expansion in 2026. What does that mean for the wider AI industry?
It really underscores how critical advanced packaging, specifically CoWoS from TSMC, is. With NVIDIA taking up so much capacity, any slowdown in expansion, it could really tighten the screws. It likely means more intense competition for that limited resource across the whole industry. Companies not at the absolute front of the line might see slower innovation or rollout.
So TSMC's capacity expansion rate basically dictates the pace for much of the AI hardware revolution.
In many ways, yes. It's become a strategic global asset.
All right, finally, let's talk about wafer-on-wafer. You mentioned its potential for edge AI. What's the real-world impact? How might you or I see this technology mature in our devices?
This is where it gets tangible for everyday users. WowW is seen as key for overcoming hurdles in edge AI processing AI tasks directly on the device, not just in the cloud. The potential for better performance and that cost reduction, about $80 per SIGI, that paves the way for more efficient, affordable AI features.
So things like smarter phones, more responsive home devices.
Exactly. Imagine your phone handling complex voice commands instantly, locally, without that slight delay sending data back and forth to the cloud. Or more sophisticated real-time processing in cars or industrial sensors. While W promises that kind of seamless, potentially more private AI experience, bringing powerful AI capabilities out of the data center and into more places.
It's clear from this deep dive how these interconnected pieces, AI demand, domestic production pushes, and these critical packaging innovations are really shaping what's next in tech. We're talking more intelligent devices, more localized AI solutions, things that will definitely change how we interact with technology daily.
Absolutely. And it does raise a bigger question looking forward. With AI and semiconductor tech evolving so quickly, how will this increasing specialization, these shifts in production focus, ultimately reshape who leads globally? And how accessible will this powerful technology actually become?
A crucial question indeed. Food for thought. Thank you for joining us on the Wall Street Podcast for this deep dive. Until next time.